Hello, in this lecture we'll find out the size of angle theta. In the drawing we have a right triangle ABC. We know that AD equals to EC and DE is twice as long as AD, and EC, or DE over 2 equals to AD equals to EC, and our mission is to find out the size of this angle, angle theta, that is equal to angle ODE. Okay, so first of all we'll define DE as 2A. Here DE equals to 2A according to our definition, and here we know that AD equals to CE equals to DE over 2. AD equals to CE equals to DE over 2, but according to our definition, DE equals to 2A. So 2A over 2 is A. So in conclusion, we found out that AD equals to CE equals to A. So you can write down in the drawing that AD equals to A and CE is also equals to A. Okay, here we have also rule number 4. According to rule number 4, the perpendicular from the center of a circle, the perpendicular from the center of a circle to a chord bisect the chord. Here we have the center of the circle is point O. So if we draw from the center of the circle, that is to say from point O perpendicular to chord CD, then it bisects chord CD. That is to say CM equals to MD. CM equals to MD. So you can implement rule number 4 in our drawing, because here if we draw from the center of this circle, that is to say from point O perpendicular on chord DE, so this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and DE as T, and according to rule number 4, DT equals to TE, and DE has been bisected by perpendicular OT. So each half equals to, so here DE over 2, it is equal to DT, that is the first half, and the second half of DE is TE. Okay, but according to our definition, DE equals to 2A, so DE over 2, it is equal to A over 2 is A. So in conclusion, we found out that DT equals to TE equals to A. Okay, DT equals to TE equals to A. So DT equals to A, and TE is also equal to A. Okay. In the next step, we define the point of tendency of tangent AB with this circle SM, we define the point of tendency of tangent BC with this circle SM. We will join points O and M together by a straight line. Point O is the center of the circle, point M is the point of the circle itself, therefore OM is the radius of this circle, so we define the radius of this circle as R, therefore OM equals to R. And we have the radius OM that is 1 to the point of tendency, therefore this angle equals to 90 degrees, and this angle will be also equal to 90 degrees according to rule number 1, and tangent to a circle is perpendicular to the radius 1 to its point of tendency. Here we join points O and M together by a straight line. Point O is the center of the circle, point N is the point of the circle itself, therefore ON is the radius of the circle that is equal to R. And we have the radius ON that is 1 to the point of tendency, therefore according to rule number 1, this angle equals to 90 degrees and this angle will be equal to 90 degrees. So here, inside quadrangle MOBN, inside quadrangle MOBN, we have 1, 2, 3 right angles. The sum of right angles is 270 degrees, so the fourth angle must be also equal to 90 degrees in order to complete the sum of the angles in this quadrangle to 360 degrees. According to the rule, then the sum of the angles in any quadrangle is equal to 360 degrees. So inside quadrangle MOBN we have 4 right angles, therefore we relate to quadrangle MOBN as a rectangle. So I write it down. Quadrilateral MOBN is a rectangle. Why? Because it has 4 right angles. Okay, I repeat again. Quadrilateral MOBN is a rectangle. And we know that the opposite sides of a rectangle are equal to each other. That is to say, MO equals to BN. MO equals to BN. Here again, MO equals to BN. And we already found out that MO equals to R. So we can write here that MO equals to R. And from this equation, R equals to MO equals to BN, we will derive that BN is also equals to R. Okay, Bn equals to R. Likewise, according to the same rule that the opposite sides of a rectangle are equal to each other, we will get that ON equals to MB. ON equals to MB. But here ON equals to R, so we can write here that ON equals to R. And from this equation R equals to ON equals to MB, we derive that MB is also equals to R. Here MB equals to R. Actually, we found out that quadrilateral MOBN is not a rectangle but a square because all of its sides are equal to each other, they are equal to R. So I write it down that quadrilateral MOBN is a square. Okay. So in the next step, I will present to you a new rule. I will call it rule number 10. According to rule number 10, so this is rule number 10. if we have this circle and we have here point P, it is an external point P. So this is actually point P, and from point P we have tangent to this circle. So we define the point of tendency of this tangent if this circle is point A, and also we have from point P we have a straight line that cuts the circle at 2 points. Okay. We define the intersection point here as point B, and we define the intersection point of the straight line with the circle as point C. We have here chord BC. According to the new rule, AP squared equals to PB times PC. Again, AP squared equals to PB times PC. So I write it down. AP squared equals to PB times PC. Repeat again. From point P we have tangent PA, and from point P we have a straight line that intersects with the circle at 2 points, point B and point C. Then PA squared equals to PB times PC. Okay, we can implement rule number 10 in our drawing. Why? Because in our drawing we focus at point C. From point C so this is rule number 10. At point C, from point C we have tangent CN, and from point C actually we have a straight line that intersects with the circle at point E and point D. Therefore, according to rule number 10, we will get that Cn squared will be equal to Ce times CD. Repeat again, Cn squared equals to Ce times CD. Here, according to rule number. So this is the implementation of rule number 10 in our drawing at point C. Cn squared equals to Ce times CD. Okay, Cn squared equals to Ce times CD. So here, so Cn squared equals to Ce. C equals to A, so we substitute Ce by A. And what is the value of CD? Here CD equals to A plus A plus A, that is 3A. So in conclusion, we found out that Cn squared equals to A times 3A. A times 3A is 3A squared. Here we'll take a root out of this equation, and we'll get that Cn is equals to the square root of 3 times A. Cn equals to square root of 3 times A. So we can write here that Cn equals to the square root of 3 times A. Likewise, we will implement rule number 10 at point A. From point A, we have here we have from point A, we have tangent AM, and from point A we have a straight line that intersects with the circle at 2 points, point D and point E. Therefore, according to rule number 10, we get that AM squared is equal to AD times AE. So here, this equation is the implementation of rule number 10, now drawing at point A. AM squared equals to AD times AE. Okay, so AM squared equals to AD is A, so substitute AD by A, and AE equals to A plus A. Here, AE equals to A plus A plus A. That is to say to 3A, so we substitute AE by 3A. So in conclusion, we found out that AM squared equals to A times 3A, that is 3A squared. Here we take out of this equation and we get that AM equals to the square root of 3 times A. AM equals to square root of 3 times A. AM equals to the square root of 3 times A. Okay, so in the next step, I will copy the right triangle, triangle ABC in a new page, and we'll analyze triangle ABC. So here's triangle ABC, that is a right triangle, of course. This is triangle ABC. Angle ABC equals to 90 degrees. This angle equals to 90 degrees. The length of side AB, here, side AB equals to square root of 3 times A plus R. Okay, square root of 3 times A plus R. Side BC is also equals to square root of 3 times A plus R. And finally, the hypotenuse AC equals to A plus A plus A plus A, that is 4A. So this is the right triangle ABC, the copy from the original drawing. We know that the sum of the angles in triangle ABC must be equal to 180 degrees. This angle equals to 90 degrees. Therefore, the rest two angles must be also equal to 90 degrees, because 90 degrees plus 90 degrees is 180 degrees. So here, but before that, we have side AB equals to square root of 3 times A plus R, and side BC is also equal to square root of 3 times A plus R. That is to say, those two sides are equal to each other. And we have the rule that in front of equal sides in the triangle, there are equal angles. So those two angles that are located in front of equal sides must be equal to each other. So if we define one angle as theta, then the other angle must be also equal to theta, because they are equal to each other. So the sum of those two angles must be equal to 90 degrees. So here I write it down. Theta plus theta must be equal to 90 degrees. That is to say 2 theta must be equal to 90 degrees. When you divide this equation by 2 and get that theta equals to 90 degrees over 2 is 45 degrees. So I found out that each angle is equal to 45 degrees. It is actually a right triangle that is also an isosceles triangle. Okay, so this angle equals to 45 degrees, and this angle is also equals to 45 degrees. So in the right triangle, ABC, it is very easy to see that cosine 45 degrees is equal to BC over the hypotenuse AC. Cosine 45 degrees equals to BC over AC. BC equals to square root of 3A plus R over AC. AC equals to 4A. So in conclusion, we found out that cosine 45 degrees equals to square root of 3A plus R over 4A. We know that cosine 45 degrees is 1 over square root of 2. So it is equal to square root of 3 plus R over 4A. Here we multiply this equation by 4A, and we get that 4A over square root of 2 equals to square root of 3A plus R. Here we can substitute 4 by 2 times 2. Over square root of 2 times A equals to square root of 3A plus R. Here we substitute 2 on the numerator here by square root of 2 times square root of 2, and we get that 2 times 2 and 2 is equal to square root of 2 times square root of 2 over square root of 2 times A is equal to square root of 3 times A plus R. Here we substitute, we will divide, we have square root of 2 in the numerator and we have square root of 2 in the denominator, so square root of 2 will get cancelled, and we left with 2 times square root of 2 times A equals to square root of 3A plus R. Here we subtract square root of 3A from this equation, and we get that 2 times square root of 2 times A minus square root of 3 times A equals to R. Here we take A as a common factor from this side of the equation. So A is a common factor, so what is left from 2 times square root of 2 times A after we took from it A is a common factor. What is left is actually times square root of 2. And what is left from minus square root of 3 times A after we took from it A is a common factor. What is left is actually square root of 3. And it's equal to R. Okay, so I found out the value of R is A times square A times 2 times square root of 2 minus square root of 3. Okay. So in the next step we will focus on the right triangle DOC, this right triangle. Here point O is the center of the circle, point D is the point of the circle itself. This is exactly the definition of a radius. That is to say, OD equals to the radius of the circle, that is equal to 1. So I'll copy the green right triangle DOT in a new page, and we analyze triangle DOT. Okay, we have triangle DOT. So this is the right triangle, the right green triangle, triangle DOT that I copied from the original drawing. This is angle theta that we are looking for. And here we know that cosine theta equals to dt over dO. So I write it down. Cosine theta in the right triangle, triangle DOT equals to dt over dO. So cosine theta equals to dt, that is A, over dO, that is R. So cosine theta equals to A over R. But we have already found out that R equals to A times 2 times square root of 2 minus square root of 3. Okay, so here we have A in the numerator and A in the denominator, so A will get cancelled. So in conclusion, we found out that cosine theta equals to 1 over 2 times square root of 2 minus square root of 3. In order to find out the value of theta, that is the value that we are looking for, or the size of angle theta, we will operate the opposite function of cosine, that is cosine minus 1 on the result, and we will get the value of theta, or the size of theta. So here the opposite function of cosine is cosine minus 1. We will operate it on the result, that is 1 over 2 times square root of 2 minus square root of 3, and it is equal to theta. When you operate the opposite function of cosine on the result, you will get the value of theta. Okay? And the opposite function, when you operate it on 1 over 2 times square root of 2 minus square root of 3, you will get that theta equals to 24.203 degrees. So actually found out the value of theta. Here theta equals to this angle theta, the angle that we are looking for. It is equal to 24.203 degrees. Okay. In the next step, I will summarize the lecture. Okay. So, in the drawing, we have a right triangle, triangle ABC. Okay. Inside the triangle ABC, we have a circle, and we know that AD equals to EC, and here DE is twice as long as EC, and it is also twice as long as ADO. AD equals to CE equals to DE over 2, and our mission is to find out the size of this angle, angle theta. So first of all, we defined DE, the length of DE is 2A. Here, DE equals to 2A according to our definition. Okay, and we have the equation that according to what is given as the equation, AD equals to CE equals to DE over 2. It is given as the equation. So I copy what is given as the equation, AD equals to CE equals to DE over 2, but according to our definition, D equals to 2A. So we can substitute DE by 2A. So here we have DE over 2 is 2A over 2. 2 over 2 is 1. So found out that AD equals to CE equals to A. So we can write here that AE equals to A and AD equals to A also. Then I presented to you rule number 4. According to rule number 4, the perpendicular from the center of a circle to a chord bisect the chord. The center of this circle is point O. We draw perpendicular OM on chord CD, and according to this rule number 4, the perpendicular OM bisects the chord. That is to say, here CM will be equal to MD. And it also divides to two halves. That is to say, CM is the first half and MD is the second half. Or we can also say that CM equals to MD equals to CD over 2. Because CM is half of CD and MD is also half of CD. So we can implement rule number 4 in our drawing. Here, from the center of this circle, that is point O, we draw perpendicular on chord DE. According to rule number 4, it bisects chord DE into two halves. Or D equals to D over 2 and T equals to D over 2. We can also say that DT equals to TE. Okay? So here DE equals to DT and each half equals to DE over 2. DE is 2A according to our definition, so we can substitute DE by 2A. So DE over 2 is 2A over 2, 2 over 2 is 1. So in conclusion, we found out that TE equals to DT equals to A. So here TE equals to A and DT is also equals to A. Okay? So here, as you can see, dt equals to t equals to a. Then we define the point of tendency of tangent AB with this circle as M. We define the point of tendency of tangent BC with this circle as N. We join points O and M together by a straight line. Point O is the center of the circle. Point M is the point of the circle itself. Therefore, OM is the radius of the circle that we defined as R. According to rule number 1, the radius OM is drawn to the point of tendency. Therefore, this angle equals to 90 degrees and this angle also equals to 90 degrees. Likewise, we join points O and N together. Point O is the center of the circle. Point N is the point of the circle itself. Therefore, ON is the radius of this circle that is equal to R. And we have the radius ON that is drawn to the point of tendency. Therefore, this angle equals to 90 degrees and this angle equals to 90 degrees according to rule number 1. So inside quadrilateral MOBN, we have 1, 2, 3 right angles. And the sum of 3 right angles is 270 degrees. Therefore, the fourth angle must be also equal to 90 degrees in order to complete the sum of the angles in this quadrilateral to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. So this angle also must be equal to 90 degrees. So inside quadrilateral MOBN, we have 4 right angles. Therefore, quadrilateral MOBN is a rectangle. Quadrilateral MOBN is a rectangle, and you know that the opposite sides of a rectangle are equal to each other. That is to say, MO equals to BM. MO equals to BN. But here, we know that MO equals to R, so we can write here that MO equals to R, and from this equation, R equals to MO equals to BN. we will derive that Bn is also equals to 1. Likewise, according to the sum rule that the opposite sides of a rectangle are equal to each other, we will get that On equals to Mb. Or On equals to Mb, but here we know that On equals to R, so we can write here that On equals to R. And from this equation R equals to On equals to Mb, we will derive that Mb is also equals to R. Here Mb is also equals to R. So we found out that quadrilateral MOBN is not a rectangle but a square because all of its sides are equal to R. Okay, then I presented to you rule number 10. According to rule number 10, if we have this circle and we have an external point P, from the external point P we have tangent PA, that is tangent to the circle at point A. Point A is the point of tendency. And from point P we have also a straight line that intersects with the circle at 2 points, point B and point C. Then according to rule number 2, AP squared, that is the square of tangent AP, it is equal to PB times PC. Again, AP squared equals to PB times PC. You can implement rule number 10 in our drawing, because in our drawing, if we focus on the external point C, we have tangent CN, and we have the straight line that intersects with the circle at 2 points, point E and point D. Therefore, we can implement rule number 10 here in our drawing. According to rule number 10, we get that Cn squared, that is the square of tangent Cn, equals to Ce times CD. Again, Cn squared equals to Ce times CD. Okay, repeat again, at point C, according to rule number 10, Cn squared equals to Ce times CD. So Cn squared equals to Ce. C equals to A, so substitute C by A times CD. CD equals to A plus A plus A, that is 3A. So substitute CD by 3A. And in conclusion, I found out that Cn equals to A times 3A, that is 3A squared. So Cn equals to 3A squared, so we took out of this equation and found out that Cn equals to the square root of 3, and the square root of A squared is A. So in conclusion, we found out that Cn equals to square root of 3 times A. Cn equals to the square root of 3 times A. Then we focused on the external point A. From the external point A, we have tangent AM, and we have this straight line that intersects with the circle at point D and at point E. Therefore, we can implement rule number 10. According to rule number 10, AM squared equals to AD times AC. Again, AM squared equals to AD times AE. Okay, according to rule number 10, here according to rule number 10, we get that AM squared equals to AD squared plus AM squared equals to AD squared times AE. This is the implementation of rule number 10 at point A in our drawing. So AM squared equals to AD. AD is A, so we substitute AD by A times AE. AE equals to A plus A plus A, that is 3A, so we substituted AD by 3A. So we concluded and found out that AM squared equals to A times 3A. A times 3A is 3A squared. AM squared equals to 3A squared. We took out of this equation and found out that AM equals to the square root of 3 times A. So we can write here that AM equals to the square root of 3 times A. Then I copied the right triangle ABC. In the right triangle ABC, AB equals to square root of 3 times A plus R. BC equals also to square root of 3 times A plus R. And the hypotenuse AC equals to A plus A plus A plus A, that is 4A. Okay, so here, those two sides, they are both equal to 3A 3a plus r, square root of 3a plus r, therefore they are equal to each other. And we have the rule that in front of equal sides in the triangle, there are equal angles. So those two angles that are located in front of equal sides must be equal to each other. So if one angle is theta, then the other angle must be also equal to theta. And we know that the sum of those two angles must be equal to 90 degrees, because this angle equals to 90 degrees. So here theta plus theta equals to 90 degrees. Theta plus theta is 2 theta. 2 theta equals to 90 degrees. We divided this equation by 2 and found out that theta equals to 45 degrees. Okay, so each angle is equal to 45 degrees. Then in this right triangle, triangle ABC, it is easy to see that cosine 45 degrees equals to BC over AC. Again, cosine 45 degrees is equal to BC over AC. Okay, cosine 45 degrees equals to BC over AC. Okay, so BC equals to square root of 3a plus r, so we substitute BC by square root of 3a times r. AC, the hypotenuse equals to 4a, so we substitute the hypotenuse AC by 4a. Okay, and cosine 45 degrees is 1 over square root of 2, so we substitute cosine 45 degrees by 1 over square root of 2. So in conclusion, we found out that 1 times square root of 2 equals to square root of 3 times a plus r over 4a. We multiplied this equation by 4a and we got that 4a over square root of 2 equals to square root of 3 times a plus r. Then we substituted 4 by 2 times 2 and we got here that 2 times 2 times a over square root of 2 equals to square root of 3a plus r. Then we substituted 2 by square root of 2 times square root of 2. So in total we have here 2 times square root of 2 times square root of 2, that is actually 4 over square root of 2 times a, and it is equal to square root of 2 times a plus r. Here we have square root of 2 in the numerator and square root of 2 in the denominator, so square root of 2 will get cancelled, and we'll have only this expression equals in total to 2 times square root of 2 times a, and it is equal to square root of 2a plus r. We subtracted square root of 2a from this equation and found out that r equals to 2 times square root of 2 minus square root of 3a. Here we took a as a common factor out of those two expressions. So here what is left from, after we took a as a common factor, what is left from 2 times square root of 2a after we took from it a as a common factor, what is left is 2 times square root of 2. What is left from square root of minus square root of 3 times a after we took from it a as a common factor, what is left is actually minus square root of 3. So in conclusion, we found out that the radius of the circle equals to a times 2 times square root of 2 minus square root of 3. Okay. Then I copied the green triangle, triangle DOT, in this new page and analyze triangle DOT. OD is the radius of the circle that is also the hypotenuse. DT equals to A, and theta, this is the angle that we are looking for. In this right triangle, we know that cosine theta equals to dt over dO. Again, cosine theta equals to dt over dO. Cosine theta equals to dt over dO. dt equals to A, so we substitute dt by A, and dO equals to R. We substitute dO by R. So dt equals to A, and we already found out that R equals to A times 2 times square root of 2 minus square root of 3. So we substitute R by A times 2 times square root of 2 minus square root of 3. We have A in the denominator and A in the denominator. So in conclusion, we found out that cosine theta equals to, so here we have A in the denominator and A in the denominator, so A will get cancelled. We left only with cosine theta, that is equals to 1 over 2 times square root of 2 minus square root of 3. And then in order to find out the value of theta itself, that is the value that we are looking for, we operated the opposite function of theta on the results, that is this expression. In this way we got the value of theta. The opposite function of theta is cosine minus 1. We operated it on the result, that is 1 over 2 times root of 2 minus root of 3, and we got the value of theta. And if we operate the opposite function of cosine, that is cosine minus 1 on the result, you will get that theta equals to 24.203 degrees. So in conclusion, we found out that the size of this angle theta equals to 24.203 degrees. Okay, thank you very much.